All right, today is about curve fitting, and before we begin, let's take a quick review here. Okay, so I've got some data on this graph here, and we've got the math equation that we're all familiar with because it is a straight line. And let's see if you can turn this into a mathematical model. I would go ahead and pause the video for a second, see if you can come up with it on your own. Okay, so the mathematical model is here, and what you're going to do is you take the height in centimeters and replace it with the physical variable, the y, and turn it into height in centimeters because that's the physical variable that you measured in the experiment. Then you've got the slope, which has its own units of rise over run, centimeters over days. Then for the x variable, there's your time in days, and then finally the b-intercept, or the y-intercept, is going to be 5 centimeters. Because it has centimeters, there's our y, and there's the units for our y's. It's going to be centimeters as well. Okay, so today we're going to write a mathematical model that relates two variables, and it's a technique which what we call curve fitting. So curve fitting is the process of matching an equation to a curve, and it's called curve fitting. And then from that curve fitting, you can determine the formula for a line that can be determined visually in doing so. And I'm going to tell you that this is not the only way to write a mathematical model between variables. In fact, your computer will do most of it for you anyway. But I want to get you used to doing this type of technique because in some ways, it's a better way of doing things than using the computer. Because the computer has different algorithms that they write, and it can throw you off the wrong path. Okay, so let's go back to the types of relationships that we should be familiar with. Okay, again, you want to know these relationships. It's just a matter of I got to know these, I've got to memorize it, and it's just something that you need to do. And I'm also going to give you a worksheet online, and you can download it or look at it at any time. But let's take a look at this worksheet that we have here. Okay, in the first column, you have the general shape of all the relationships. And then next to that is going to be the written relationship between the two variables. I'll get into what these are in just a moment. So when we modify or change the equation, this is what we're going to do. For the first one with no relationship and the linear relationship, you don't do anything to either one of those graphs because there's already a relationship that you can write down between the two variables. But the other three, you're going to have to do some modifications to the variables to get it linear. And then finally, the last column is going to be the algebraic representation of those two variables. Okay. So let's take a look at relationship here. So I've done an experiment, I've collected the data, and once I've collected that data, I went ahead and graphed it. And this is what it looks like. But again, our goal is to linearize this stuff and turn it into a form that we can all recognize. Okay, I cannot, from first glance, come up with an equation that's going to relate these two variables. It's a little difficult for us. You need a very powerful computer to do it for you. Okay, so take a look at your the handout online there, and you'll see that there's several possibilities here, and we don't know which ones that we can use to linearize it. So, taking a look there, and if you look down, which one of these graphs kind of looks like this one? And if you look carefully there, especially if you have the worksheet open, you'll see that it's this one right here, okay? So we're going to take that box and take a look at it, okay? So we've got a general shape, and it looks like that. And then one thing we can say is we can write the written relationship, okay? So instead of x and y, we're going to go ahead and throw in the variables that we measured. So for x, we measured volume. For y, we measured pressure. So we can write the written relationship between these two variables based on this shape. And it is as the volume increases, pressure decreases. Pressure is inversely proportional to volume. That's exactly what we're saying here, but instead of x and y, we're using volume and pressure. Moving on. Okay, so the next column over says modification required to linearize the graph. Okay, so here is my original data right there. And it tells me that I need to graph y versus 1 over x. Okay, so my y, I haven't done anything to it, so here it is. All right. Now for my x, I have to take 1 over x. So instead of 1 over x in this experiment, it's 1 over volume. Remember, our units and variables get treated the same way, just like numbers, so it's 1 over meters cubed for our units. And so I'm going to show you how to do this in class, but what I've done is taken every one of these values and put 1 over that value. And this gives me new data to work with. Okay, so now if I graph that data, what you'll see here is that, wait a minute, we have a straight line here. That's kind of cool, because then what I can do with that straight line data is I can turn it into y equals mx plus b. So for y, I didn't do anything for it. It's pressure. Okay, for the m, for the slope, I got the computer or Chromebook to calculate the slope for me. All I have to do, though, remember, is that my units are going to be rise over run, 1 over meters cubed. Here's my rise. My run, now because I put 1 over volume, my units are going to be 1 over meters cubed. This should be 1 over meters cubed here, but I forgot to put it in. And then for my x, I'm going to take this here and place it over here. Now, because we have a y-intercept of 0, it's 0, so we don't have to worry about it in this mathematical model, but here it is, and this is about as easy as it gets, okay? Okay, so first thing we need to do, I'm going to review this real quick. So we need to take a look at the graph, see what it looks like. Then we compare it to that worksheet, and we find out which one of the relationships that it looks like, the general shape. From there, we're going to go ahead and manipulate our variables based on whatever our worksheet tells us. In this case, it's 1 over x, 1 over x. And then finally, we use this new graph to generate a new mathematical model. And this is how we relate the two variables that we measured in an experiment. It's called the mathematical model of these two variables. Okay, so today, what we did is we wrote a mathematical model that's going to relate two variables in experiment.